Good evening. Okay, so far you have learned how to convert, how to check the code, and from the code you get the complexity. Okay, so now you can see the real code. So, for example, I will take week 6 lecture. So in week 6 lecture, we have bubble sort code. So if I were to do analysis for this particular code, remember you need to concentrate on the looping structure. So here I have 2 for loop. So this is the first one and this is the second one. So the question that we need to ask is the second for loop is inside the first for loop or is it outside? Inside or outside? Inside. So nested for loop. So meaning the relationship between 1 and 2 is times. Clear? Now what is the complexity of the first for loop? 0 to size. What is size? Size is your input. Okay. So this is similar to n, and this is also n. So meaning the first one is n. Clear? Now the second loop is from 0 to size minus something, but originally is still size. And what is size? N. So the second loop is also n. So the big O for this is n times n square, O n square. Clear? Now let's see selection sort. Now similarly, we will check for the for loop. So here I have 2 for loop, the first one and the second one. And again, we ask that question: is the second for loop is inside first for loop or is it outside? Inside. Okay. So again, the relationship is 1 times 2. So what is the complexity of the first for loop? Now notice here, this is size down to 0 because this is minus minus. So size comes from this. So this is n down to 0. Now normally we do 0 up to n, but this one is the reverse, from n down to 0. Regardless whether it's from 0 to n or n to 0, it is still n. Clear? So the first one is n. Now the second one is from 1 until rightmost. Now what is rightmost? Rightmost is taken from n. So the second one is also n. So the complexity for this is n square. The big O is O n square. Clear? Any question? But in certain cases, your code is very long. Okay? And in certain cases, the code is very complex. It involves recursion and so on. So it becomes very time consuming to come up with the complexity. So as the last resort, if it is very difficult or it's very time consuming, then we can use timer. Okay, stopwatch. So we can create a graph You can do in Excel as well if you want to, in a spreadsheet. Okay. Graph of time versus size. So, for example, if I have 10,000 items, then I thought I will get certain time, for example, 3.5 seconds. So what I need to do is, I need to plot the graph. For example, this is 20,000, 40,000, 60,000, 80,000. And if there is a need, I need to put more. Okay. And for time, for example, this is 30 seconds, 10 seconds, 20 seconds, 5 seconds, 15 seconds, 25 seconds. So based on the size, then I can plot the time. Now the idea is, you put variable number of size, then you run multiple run, because you try to get the growth rate based on the graph. So for example, if I get something like this, then I know that this is linear. If I get something like this, then I know that it is logarithmic. If I get something like this, then I know that it is exponential. Clear? Okay. We may not be able to get the actual BO, but if I can estimate whether it's a constant logarithmic, then I can easily make comparison. Clear? So we'll try this using our program that we already did, for example, last week. The bubble and selection sort. This one, okay. Now, because we are going to time this, if I use online, it might not be very accurate. Okay, not that it is not fast, but the time depends on the loading, the server loading. If you're lucky, then you get 100% of the CPU time. If you're not lucky, somebody else is using, you don't get the full CPU time. Okay, so the time can be influenced slightly. So it might not be accurate. So I will run this locally using local compiler. Okay, you don't really need to. You can still use the online. You don't really need to use the local compiler, because we are running just one program. The program that I'm using is like 10 gigabyte. Okay, so it's not really worth running one program for 10 gigabyte. Now I'm going to use Visual Studio Community, which is stated here. Okay, Visual Studio Community 2022. This one is free. Okay, don't confuse this and Visual Studio Code. Visual Studio Code is different. This is Visual Studio. Once you have installed it, it will ask you to choose the component, okay, that you want to install together. So you need to choose this installation option, desktop development with C++. Okay, so you need to have this for C compiler. So this is my installed Visual Studio 2022. So just create new project. Console application. Console application means the one without any user interface, no GUI. I want to put inside my own folder, so I will change the folder. So I will put inside section 11, section 10. So I will copy paste the code that we did last week, which is this one. Okay, my complete bubble and selection sort. So we'll copy this. Okay, and paste here. Yeah, there's some errors here. Size. Like this here, size is ambiguous because for this particular compiler, size is used internally. Okay, so I cannot use this word size. And I change the name, or I can just get rid altogether. Okay, I can use this max. Now, 10 definitely not enough. Okay, because we are going to type this, so we need to have some significant processing time. 10 is instant. So I will increase this to 20,000. Okay, and then when you do the sorting, I don't want to output anything because this output will influence or will affect my timing. Okay, what we want is pure sorting time. So I will take this out and take this out. Likewise, you need to do for selection sort. Okay, so take this out and take this out. Clear. So no input output should influence the processing time. Okay, next is this size, so I can remove this. So instead of size, I will use max L. Okay, so okay, and then this one is max L. Okay, and then the content, okay, of the array. Now definitely I cannot do this method anymore. It's 20,000 items, so I will use random numbers. So we create a simple loop and then we put random numbers inside. Clear. So just a simple for loop. So I will use ran is a random function number. So it will give me an integer number, so from 0 to 65,000 or something. Now I don't want huge number. Okay, I want just a small number as a random number. So what I will do is I will mode this by 100. So the number is limited to 0 from 0 to 99 only. Okay. Have you learned this modulus remainder? For example, if I say 17 mode 4, or sometimes also is written with this percentage symbol, okay, for modulus. So 17 mode 4, what is the value? 1, okay. So basically 17 divided by 4, and what is the remainder? 17 divided by 4, the remainder will be 1. Clear? So if I divide anything with 4, the possible remainder is 0, 1, or 2, or 3. So if I mode by 100, then the possible value is 0 to 99. Clear? So I limit the number between 0 and 99 only. Okay. Okay, then I copy the list to be list. Okay, and then I will check. Okay, I will see the content just to make sure that this is done correctly. Okay, so run. Remember, I'm going to display 20,000 number. So this is the content. You can see the number inside is 0 to 99. It's a random number, but 0 to 99. Clear? Now notice also the last number is 3351. Okay, 3351. So when I run again, I still get 3351. Okay. Now this is the mathematics of random number. It's beyond this class discussion. But basically it's a random number, but the sequence of random number is the same. Clear? Because the random number is generated from a seed number. So if the seed number, this is a number before your first number, a seed number. If the seed number is the same, then the sequence will be the same. Okay. So in this case, the seed number for this particular program is the same. Now, if I want it to be different, then every time I start, I need to ask for different seed number. So one way is I ask the user to enter any number. The next time the user run, they need to enter different number. Then I get different number. Okay. But the problem with that is not very convenient. You can imagine that every time the user run, they need to put some numbers. Okay. So another way is to find a number that will change every time you run. What is the number that will change every time you run? Every time you run, what will change? Time. Clear. Time will change every time I run. So what I can do is I can create a seed number based on time. Now remember, here the time that we see is what 6:29, but internally for the computer it is not measured in just in seconds but also in milliseconds. Okay, so definitely when you run, the millisecond will be different. So to create that seed number, so I will call sran. Sran is to set seed number. Okay, I will call time. Okay, time function, time null. Okay, so it will extract whatever current time is in millisecond. Okay, so run, not in terms of the actual time, but it's converted to numbers. So now you can see this number changes. Okay, if I run again, this is 70:95. So now it's 16:18. Clear? So it changes. But sooner or later, some sequence will repeat again, okay, because it's not a true random number. Okay, this mathematical random number is not a true random number. It's the same like when you play games. If you play long enough certain games, even though the appearance of certain object is random, but you can predict. Okay, sooner or later, if you play enough, you can predict where it will come from, because the random is not truly random. Okay, so after some time, it will repeat. Okay, so now I have the items, so I don't need to display anymore. I know that it works. So I can call bubble sort, and then what I will do is I will get the timing. How do we get this timing? So what we will do is before we start, so this is the bubble sort. So before I start, I will get the current time. Okay, current time. So in the actual time format, so time before equal to clock. Clock will give you the current time, okay, including the millisecond. Then you sort, and once you have sorted, you call time after. So you take another time. So for example, this is 6:32, and then after you have sorted, the time is 6:34. So time taken equal time after minus time before. So you will get 2 minutes. Clear? So that's basically how we time this. Of course, our time will be in seconds, not in minutes. Okay, so now to save the time, it has to be inside a special type called clock T. Okay, so this allows you to store the time in the form of the real time. So time before, then time after. Now time taken is just the difference, so it can be in double. So I will call it time taken. So before we do the bubble sort, we take the time. So time before equal clock. So this will extract current time. Okay, current time. Then we do the sorting. Then we take another time. Time after. Okay, then we can see the difference by subtraction. So time taken equal time after minus time before. Clear? So now I can output the actual time. So see out. So given the size n equal to whatever inside that max L, T equal to T is time, so time equal to time taken. Now we want to put this in second, easier to see. Okay, that's it. Run. So I will get something like this: n equal to 20,000, t equal to 1056 seconds. Because the time is in millisecond, I will get 1056. So if I want to convert this to second, I need to divide by 1000. Okay. Now, if you divide 1000, you get integer. I want fraction, so 1000.0. So 1.08 seconds. Clear? Now, to be certain, I will run this again. Make sure the number is almost the same, 1.07. So I can safely say that it took 1 second, okay, to sort 20,000 using this bubble sort for this particular machine. Okay. Now, if I were to run this using the online compiler, you get 1196.9. Now, the emulator is using Unix, must be Unix. So, Unix system use, I think, nanosecond or something. Okay, so it's divide by 1 million. It's microsecond or something. So you need to divide by 1 million. Same with Mac, because Mac is Unix based. You need to divide by 1 million. Okay. You can see just now it's about 1 second. Now it's 1.5 seconds. Okay. So the time fluctuation for online is a bit more. Okay. So it's really not really predictable. But if you can get some consistent number, then you can accept that. Okay. 0.1.4 now it's roughly 1.6. 1.5, now 1.3. So you can see it's still usable, but the time might not be accurate. Okay, so that's why we use a local compiler for this exercise. Okay, so now I can plot the graph. So 20,000 roughly 1 second, so roughly here. So next I will do 40,000. .01. Now, I cannot rely just on one result. It could be an anomaly. So I can try to run again. If I get something close to 6 seconds, then I will accept the result. Okay. .7. So it's close to 6 seconds. So I will set that 6 seconds. So 40,000 is somewhere here. Okay, then 60,000. If you want, you can use Excel to plot this as well. Okay, 60,000. Remember, now it will take a longer time and longer time. Okay, so longer waiting time. 14.9. Okay, it's something 14.9. So I will run again, make sure that I get something closer to that. Okay, so I will take 40. I will take that 14.9. Now remember, if you use online compiler, actually is not that bad. Okay, it's not that bad. You can still use it. Okay, you can still use it. Normally, if the size is bigger, then the time will not differ that much. Okay. If the size is smaller, then probably the time fluctuation is bigger. So you can still use this if you want to, as long as you get the growth rate. So 16.7, roughly about 17 seconds. So somewhere here. Okay, and then 80,000. Now definitely is a bit longer. Okay, so you just have to wait. $27.9. So I will run again. Make sure I get something closer to that. Okay, 27.1. So I can safely say it's roughly about 27. Okay, so roughly somewhere here. Now from this, I can see already the growth rate. Okay, so I can conclude that the growth rate for this is exponential. Okay. Now if you run a selection sort, you will get something like this. So it is exponential, but it is faster than bubble sort. Okay, so you can conclude it is faster than bubble sort just by looking at the graph. Clear. So when there's no other ways, or if it's too time consuming to analyze the code, then you still have this option to try to get the growth rate using graph. Okay. Any question? Any question? Any question? 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 Okay, you can take your break. Come back at 6:55. Okay, let's continue. Okay, go to week 9, 3, exercise 1. So do this. So you have 9 minutes. There are 9 questions altogether. Four minutes. Now remember, you can use formula or you can use common sense for this. Okay. In this case, common sense makes more sense. Okay. Because if you use formula, you may make some mistake, and worse is you will repeat the mistake again and again. Now, if you want to use common sense, just make sure that you know how to read this. Okay. First level, second level, then you have third level, fourth level, fifth level, sixth level, and so on. Clear? So the number of items in the first level is 1, second level is 2. Okay, so third level is 4, 8, 16, 32, 64, 1 to 8, and so on. Clear? Now, if I want to know the total nodes or total elements up to this level, okay, up to this level, so I can add 4 plus 2 plus 1, or I can just count 8 minus 1. Clear? If I want to know the total for up to this level, the total of this, you can count everything, or basically it is 32 minus 1. 32 minus 1. This whole thing is 31. Clear? This is all that you need to know. Okay. Okay. First question. Mat Tasin Al-Arabi. Tasin. Not here. Muhammad Hamza. Minimum, maximum. $63 no. Maximum. Minimum. 63 notes means maximum, right? Let's say you have 3. What is the maximum height I can do? I can do it this one. Yeah, that's 3. So 3 meaning height of 3. That's the maximum. That's the maximum. So if I have 4, height is 4. So it's maximum 3. And if I ask you how do we fit this into one line, it's possible for millimeter straight. For the minimum. Yeah. Okay, you have 63, right? Yeah. This is basically 64 minus 1. So meaning you're here. How many levels? 61, 2, 3, 4, 5, 6 levels. Clear? Yeah. And minimum is 6 levels. 1, 2, 3. Okay, so here's 63 items. 63 items, okay. So what is the maximum height that you can build? Now, if I have 3, maximum height I can build is I just link them all together. So I will get 3. Here. If I have 5, then I just link something like this. 1, 2, 3, 4, 5. So meaning if I have 63, the maximum is 63. Clear? Common sense, okay? Now, if I want to have minimum meaning you make it as compact as possible, as shallow as possible. So you put everything inside this, right? So 63 is going to be 64 minus 1, which is this whole thing. So 1, 2, 3, 4, 5, 6 level. Clear? Height of 6. Any question? Any question? Question? Clear? Common sense, common sense, common sense. Next. Lo Kang Sheng. Three degree. What is the 3 degree? What is 3 degree? What is 3 degree? Maximum number of children at any particular nodes. This is binary tree, so the maximum you can have is 2. Clear? Next, Muhammad Mahin. Parent. 1, 2, 3, 4, 5, 6, 7. So if I want to find parent of 7, I divide by 2, I will get 3.5. But there's no such thing as 3.5. Okay. So if you remove the fraction, you get 3. So parent of 45 divide by 2, you get 22.5. So it's 22. Clear? Next, Li Jiafeng. One. So 31, definitely maximum you just change everything, you get 31. Clear? Minimum, you put everything. So 31 is 32 minus 1, so meaning this level. 1, 2, 3, 4, 5. Clear? Any question? Any question? Next. Muhammad Shabir. Okay, divide by 2, 13.5. There is no such thing as 13.5. 13. Next. Ko Ching Yao. Something like this. Height of 6. So maximum. 64 plus 1 is 6. And minimum 6. Okay, now this one is height of 6. So given height of 6 meaning 1, 2, 3, 4, 5, 6. Okay. So if you need to build height of 6, what is the minimum element, minimum node needed? So I can just change this 6. Like 1, 2, 3, 4, 5, 6. So minimum 6. Clear? Maximum, I put everything together, right? So I have 6 level, 64 minus 1, 63. Clear? Common sense, common sense, common sense. Next one. Muhammad Yamin. Children.
When I can left children, right?
Just put two. Two of them.
Going to 30, right? Going to 30. And the load is 30.
Children. 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 30. Then
30 into
times 2, times 2, 4, 5, 6, 20, 10.
61.
Okay, so times 2. 60 left, right children, 61. Okay, don't forget this is left and right. Gladson, Nixon. Minimum, maximum height of 7. So minimum, 7. Maximum. If I want to know the total of this, I see the next one. Wait, the next one. 4, 1 to 8, minus 1. Okay, so height of 7. Okay, height of 7 is this 1, 2, 3, 4, 5, 6, 7. So minimum, just take 1, 2, 3, 4, 5, 6, 7. Maximum. If I want to know the total of this, I go to the next level. 1 to 8 minus 1, 1 to 7. Clear? Last one. Tan Weng Hong. Tan Weng Hong. Fardin. Height maximum is equal to so the maximum number is 1. When it comes to the because you are looking at the low okay, not possible or no children. Clear? Okay. Remember, the height is 7, so the maximum that you can have is 1 to 7. So 1 to 7 is the last node. 122 must be somewhere here. So there is no children below this. So there is no children. Clear? You are at the bottommost last level. So 1 to 2 is what we call the leaf node. Clear? Okay. Any question? Any questions? Okay, now go into your big group. Group 26, group 37. Don't discuss any subgroup. Okay, no subgroup discussion. Strictly big group. Strictly video assignment. Clear? So the supreme leader take over.